Good morning. My name is Alan Russell. This is week 2 of FTT 122, Introduction to Ammunition and Basic Ballistics. Today is Saturday, August 16th, 2025, and we are going to talk about the effects of materials on cartridge casings and ballistics. This is going to be a 3-part presentation, and the first part will discuss the features of a modern case, why they've been designed the way they have. Part 2 will go into discussing the weaknesses in the modern case design, and if there's any improvements that can be made, as well as what these alterations to improve the design would cause as far as changes it would have on the ballistic performance. Then we're going to end the discussion on the third part with how the materials used to create the casings affect the expansion of the casings and also the performance. According to our text, Introduction to Ammunition and Basic Ballistics, the main part of the casings are the case body, which is this part right here, the base, which is this very back part here, the primer pocket, which is this little, I don't know if you can see it, this little hole in the back, the flash hole, which you can't see, it's in between the primer pocket and the inside in the case where the powder is at, and then the mount or the neck, which is this part right up here, right? The case body is where the powder is stored, and also where the primary components. It's also the primary component of the shell. The base is the rear of the casing, which includes the rim right here, or any grooves that might be there that aid in extraction. The primer pocket is a recessed hole that holds the primer, so it just pops right in there. The flash hole is a tiny hole that connects the primer pocket to inside of the casing where the powder is stored. And then the mouth or the neck is the opening at the front where the bullet is actually inserted. So you can see where the bullet goes right into the casing right here. And that's typically crimped to hold the projectile in place. Our text gives us several reasons for the design being the way it is. Structural integrity for one. Basically, the design of the case allows it to withstand very high pressures without rupturing. It also helps create a gas seal. When the case expands, it seals to the chamber and creates a very tight seal, preventing blowback and ensuring that the maximum pressure is applied to the projectile. And then finally, extraction. This is where the rim or the groove on the base is designed to basically aid the extractor in the weapon to remove the round or spent casing from the chamber when after firing, right? So additionally, you have head spacing, and the head spacing is vital for safe and consistent ignition. And features such as the rim, the shoulder, and the case mouth serve as a point of reference to ensure that the head spacing in the chamber is correct. And finally, at least in the case of brass cartridges, it also allows for reloading, which allows us to replace the primer, powder, and bullets to produce a more cost-effective practice. It allows some people to create custom loads for like precision shooting and things like that. So weaknesses in the current case design are there's a couple actually, but primarily used materials. The primary used materials such as brass and steel each have their own set of issues. For instance, brass is more expensive, and heavier, but it provides a superior seal and it's reloadable. Steel is much cheaper, but causes more wear on firearm components, and is just generally less reliable because of its lack of elasticity. And finally, aluminum, while it's a soft metal, it does expand, but it doesn't contract, so it's harder to extract, and it has its own problems. You can't reload it and those kind of things. So, additionally, due to the materials being used, there are inconsistencies in the manufacturing process. So the forge and drawing methods have basically inherent microscopic variations in the case wall thickness and also internal volumes. These little inconsistencies can lead to very slight variations in the chamber pressure, and that's going to affect muzzle velocity in between shots. So there are also limitations on reloading, and brass has a finite lifespan and can only be reloaded so many times, primarily because of repeat firings and resizing of the cases, expanding and contraction leads to head separations or metal fatigue, basically, so which could cause head separations or other failures. There are a lot of improvements that are under development. The three that I found that kind of stand out to me is going to be um, polymer hybrid casings, and that involves a polymer body with a metal case. This would create a much lighter cartridges and provide a more consistent case dimension, thereby generating an improvement in muscle velocity and to improve consistency and accuracy. There's also some talk about 3D printing. If this were to be accomplished utilizing advanced manufacturing processes, it can produce near perfect uniformity in geometry. By ensuring each cartridge has an identical internal volume and wall thicknesses, shot consistency would be dramatically improved. And finally, creating cartridges without casing is under development or under investigation. And that would just really revolutionize the firearm industry. Primary benefits of caseless cartridges would be a drastic reduction in weight and a total elimination of the extraction and injection process. This would allow firearms to be designed that are lighter, less complex, and provide possibly a higher rate of fire. So when a cartridge is fired, the gases created force the casing to expand. That's going to create a seal in the chamber walls with the cartridge against the chamber walls. That's going to help prevent blowback, as I mentioned earlier. It's going to be extremely important to the operation of the weapon. Right? Probably the most common material used to make cartridge casing is brass, and the next common is steel. Um, primarily because I think brass is a superior product. Brass is more elastic and it creates a superior seal, and it contracts after firing, so it extracts easier. Um, Steel is just not going to create as good a seal as brass will, and it's going to be more difficult to extract, and it's also prone to fouling in the weapon. So, although it is cheaper than brass. Um, Aluminum is a soft metal also, but it has less elasticity than brass. And what that means is while it's going to expand well, it'll make a pretty good seal, better than steel, but not as good as brass. It doesn't contract as well. So after you fire, it's not going to contract as well. That's going to make extraction more difficult, right? Um, and, and the impact that's going to have on the projectiles, according to Hornady's Handbook of Cartridge Reloading, it says brass is going to provide the best seal, and it's going to provide a more predictable muzzle velocity and much better accuracy. Steel and aluminum casings are less effective and going to cause more pressure variations and a minor decrease in accuracy. The trade-off there is they're going to be less expensive than brass. And of course, the properties of the material also affect the reliability of the spent casing's extraction and ejection, as we were talking about. Um, to sum everything up, I think the general consensus among firearm manufacturers and industry professionals seem to be that brass provides the best performance and it's reloadable and reliable. However, it is the most expensive of the three, right? Steel is the least expensive of the three, but it's dirtier, less reliable, and you can't reload it. And additionally, it causes more wear on the weapon, right? With aluminum's cost being somewhere in between, even though it's a lightweight round, it's not reloadable and can cause more fouling than brass, and its accuracy and reliability is not as good, right?